I forget to record every time. Okay, so plastics, we have started with the plastics, which is a form of polymer. And we have seen its definition that they are nothing but they are basically synthetic organic materials. They have high molecular weight and they can be molded into any desired form from one form of the plastic to another form when these plastics are subjected to temperature, pressure, and in presence of catalyst. Okay, so these are some examples of the plastics which we use in our daily life. Okay, आप लोग देखते होंगे we are using these bottles, tiffins. Okay, the many other examples are there here. So all these are your and how originally they look like. Basically, these are the granules of the polymers which can be made into the sheets, which can be molded into any desired form. So these are the samples of polymers. So in market, basically these kind of polymers, they are available in the market for synthesis process. Like if some company is going to buy PP, that is polypropylene. So he to make some article, so he will buy these kind of granules, or these are the samples he will see for the polymers, and from that they will buy this, whether they want 10 kg, 15 kg, or 20 kg. So according to their requirement and need, they will buy these polymers and they are going to make these articles out of this. Okay, so these are the different articles we generally use in our day-to-day life. So these are all made up of plastics. Then we are going to see properties of plastics. So some property will be same as of polymer because plastic is nothing but it's polymer, but some property will differ. Okay, so here we are going to say that they are lightweight. Okay, as we know that polymers are lightweight materials. In spite of having high molecular weight, they are light in weight. Okay, they have transparency. That means you can prepare transparent polymers also, as well as you can add pigments into it to make it colorful. So, but you can make it transparent polymers also. So transparency, then low cost, as compared to the metals, the polymers, they have low cost and having the same properties like metals. Then durability is also more. It is having long life. Polymers, they have long life. Then they cannot get corroded easily. They have low electrical and thermal conductivity. Okay, so unless and until we prepare it as a polymer, conducting polymer, then only they will conduct electric current. But otherwise, mostly all polymers, plastics, they are having low electrical and thermal conductivity. Then resistance to corrosion, which I already told you that metals, they undergo corrosion, they get corroded, and that is they can destroy easily, they can get destroyed, but polymers, they have corrosion resistant, they does not get corroded. Then next is resistance to water. आपको पता है plastics are resistant to water. आप उसको आपका अगर the articles which are made up of plastic, we can wash it with water also. Okay, all those articles which you have seen, bottles, tiffins, then we also use your chair, table, buckets, mugs, all that, whatever we see, stools we see at home, all that can be washed with water. So that means they are resistant to water. Then ease of manufacture, they can be easily molded into any shape and size. So manufacturing is easy. So ease of manufacture. Then they have low toxicity. So if we again here, there is one thing which we have to remember, which we will study in the green chemistry chapter in second semester. So there we will relate this, how these polymers can have low toxicity. Otherwise, basically, when you talk about plastics, rubber, etc., or the organic compounds, some compounds are toxic in nature. So if we are going to use the monomers as the toxic compound, then our polymer will be toxic. And if we are using non-toxic chemicals, then our product will also be non-toxic in nature. So especially we have to take care when we are making the toys out of it, because these small kids, they put the toys into their mouth. कि आप देखे होंगे कि बच्चे, छोटे बच्चे क्या करते हैं, जो खिलौने से खेलते हैं पूरा उसको मुंह में डालते हैं. सो अगर वो आपका प्लास्टिक मटेरियल, वो आपका रबर मटेरियल टॉक्सिक है, देन दे आर गोइंग टू हार्म द स्टूडेंट किड्स. Okay, so that's why the toxicity has to be taken care when we are preparing these articles like toys and all. For other articles also, then they are resistant. They show resistance to heat and glass transition temperature. We have already studied this regarding the glass transition temperature, that it is the lowest temperature below which the polymer becomes hard, brittle, and glass-like material, and above which it becomes soft and flexible. Okay, so they have the resistance towards this heat, and that's why they have a glass transition temperature. Till that point we can use it. So these were all properties of the plastics. So they are nothing but they are related to the polymers only. So all the properties of polymers is same as plastic, because plastic is itself a polymer. Is it clear, students? Any doubt?
No, ma'am.
Please clear it out. Okay. Then next we have types of plastic. Okay, so we have to see what are the two types of plastics. You have already, I think, studied in your 11th and 12th. Yes, any student, can you name it? What are the two types of plastics? If you remember, please just review these topics we are revising basically. So what are the two types of plastics? Nobody knows? Okay, have you heard about thermo-softening and thermosetting plastics? Yes, students? Have you heard about thermo-softening and thermosetting plastics? No?
No, ma'am.
Okay, मतलब आपने नहीं पढ़ा है. Okay, no,
yes,
not an issue.
मैम मैंने सुना मैम.
मैम हम लोग के
पढ़ा है?
12th का हाफ पोर्शन डिलीटेड भी था ना मैम.
हाँ हाँ.
शायद वो पार्ट नहीं था शायद.
ठीक है. Okay, वो पार्ट नहीं पर ठीक है. Okay, not an issue. But here it is important part, because the questions can be asked on this topic, that write the difference between thermo-softening and thermosetting plastic. So this question is important here in engineering. It can be asked in exam. So you have to study this topic here, types of plastics. So we have two different types of plastics. Thermo-softening plastic, which is also known as thermoplastic. Okay, and the other is thermosetting plastic. तो दो तरह के, एक थर्मोसॉफ्टनिंग, थर्मोसेटिंग. थर्मोसॉफ्टनिंग को हम लोग थर्मोप्लास्टिक भी बोलते हैं. अभी यहाँ पे मेन डिफरेंस क्या है दोनों के बीच में? थर्मोसॉफ्टनिंग जो प्लास्टिक है वो आपका लीनियर और ब्रांच चेन पॉलीमर है. मतलब उसका जो स्ट्रक्चर है, उसका जो पॉलीमर का स्ट्रक्चर है, इट कैन बी ऑलवेज लीनियर चेन स्ट्रक्चर, और इट कैन बी ब्रांच चेन स्ट्रक्चर. But thermosetting polymers, the thermosetting plastics, they have three-dimensional network chain structure, or you can say cross-linked structure. Okay, so this is the main difference. So now we will see. So this is your thermosoftening. As I told you, it can be branched or it can be long linear chain. So it can be a straight long chain or it may be branched. But here you can see in thermosetting type of polymers, you can see that all the layers of the plastic or the polymer, they are interconnected with the another layer of the polymer. Okay, तो ये सब बीच में जो रेड कलर के आपको बॉन्ड्स दिख रहे हैं, they are nothing but they are the cross link between the polymer molecules. Cross link. So because of this cross linking, this polymer becomes very hard, strong, and these bonds cannot easily break. जैसे बीच में आपका intermolecular forces, उसी तरह से ये आपका आ गया यहाँ पे cross-linked bonds, cross-linked polymers, they are known as, because these are the cross-linking between the polymer molecules. They does not allow the polymer molecules to slide over each other. These bonds will help them or they are very strong bonds. They cannot break easily at temperature, high temperature also. So because of that, they are thermosetting. So this is the difference. This kind of structures we have to see. This is thermosoftening and this is the thermosetting. Okay. Now we will see what is thermoplastics or thermosoftening plastics. Okay, thermosoftening plastic is also known as thermoplastics. So maximum 80% of our polymers, they are basically thermosoftening plastics. So here you can see that this is a thermoplastic material having long straight chains. Okay, these are the polymers of the plastic. Okay, molecules of the plastic. So this is thermoplastic. So in thermoplastic, there is no cross-linking. Either it can be straight chain or it can be branched. So you can see here that these are having no branch and no cross links. They are straight chain molecules. When these type of compounds, that is thermosoftening polymers, they are heated at high temperature, they are going to change their shape easily. As I told you that polymers can be remolded into any desired shape and size with application of heat, pressure, and catalyst. Okay. So here you can see that the same polymers has converted into another shape. So weak forces between polymer chains easily broken by heating, polymer can be molded into new shape. तो सपोज इसका शेप ऐसा है, यहाँ पे आपने उसको जब हीट किया, यू कैन मेक these kind of shapes. So what I want to say that here in case of thermosoftening plastic, as there is no cross linking between them, so there are weak forces between them. So these weak forces, when you are going to heat the polymer, these weak forces can break easily and these plastics can be molded into any other desired shape, that is new shape. Okay. So there is no cross. What are the points of these thermosoftening plastics? There is no cross link between the chains. Okay. They have weak attractive forces between the chains, which can be broken by warming or heating. Then they can be molded into any desired shape and size. So they can change their shape, can be remolded. Okay. And they have weak forces reform in new shape when cold. तो जब आप उसका गर्म रहेगा तो वो तो molten form में रहेगा. You can make this, you can use this molten form of the polymer to make the another desired shape. And when it will be cold, ठंडा होने के बाद आपको वो आर्टिकल हार्ड फॉर्म में मिल जाएगा, न्यू शेप में मिल जाएगा. सो वीक फोर्सेस हेल्प्स इन रिफॉर्मिंग इन न्यू शेप. मतलब वो क्यों आपका चेंज हो रहा है न्यू शेप में? बिकॉज दे हैव वीक फोर्सेस बिटवीन द मॉलिक्यूल्स एंड बिकॉज ऑफ दैट ऑन हीटिंग दे कैन चेंज इट टू न्यू शेप. एंड व्हेन कोल्ड, व्हेन it is cooled down, you can get the desired shape. Is it clear, students? Thermosoftening समझ में आया क्या है?
Yes, ma'am.
Any doubt? Because these points you have to remember so that you can write the difference between thermosoftening and thermosetting plastics. Okay, दोनों के बीच का difference बहुत important है, वो exam में आता है. So you have to keep it in mind, these points regarding thermosoftening plastic or thermoplastics. Now we will see the next type, that is the thermosets, thermosetting plastic. So thermosetting plastics are also known as thermosets. जैसे हमने उसको बोला ना thermoplasts. So similarly here thermosets. Thermosetting is known as thermosets. So here you can see the structure of the molecules of these kind of polymers, thermosetting type of polymers. So these are the thermosetting polymers, and you can see that they have extensive cross links between them. Extensive means more number of cross linking is there. So all these bonds which you can see between the different polymer chains, they are nothing but they are the cross linking between the polymer molecules. And because of these cross linking, when you are heating it at high temperature also, they are not going to mold into other shape. They will remain as it is. वो आपका जल जाएगा, आपका जल के हार्ड सब्सटेंस बन जाएगा, लेकिन वो आप उसको मोल्ड नहीं कर सकते. ऑफ कोर्स यू कैन चेंज द शेप. जैसे आपका एक थर्मोसेटिंग क्या है, ओके, लैपटॉप पार्ट्स, टीवी पार्ट्स, okay, these are all made up of thermosetting polymers. The body parts of the laptop, body parts of TV, okay, so these are made up of thermosetting type of polymers. Now when they are going as waste, e-waste materials, आपको पता है nowadays we are generating lots of e-wastes and they are dumped into the grounds and we are not able to remold it, because they are made up of thermosetting polymers, which is having cross linking between them. When you are hitting it at high temperature, they are not going to modified into another shape. So when you will heat these kind of polymers, they will burn and they will form a big mass, but it cannot be changed into any. आपको लगेगा कि चलो अभी ये सब इतना सारा लैपटॉप पुराना हो रहा है, लोग खराब हो रहा है, फेंक रहे हैं, उसको हम लोग मोल्ड करके हम लोग दूसरा शेप बनाते हैं, या वी कैन यूज फॉर अदर पर्पस. You cannot do it. Okay, that's why the issue has become a very big global issue for the e-waste materials. क्योंकि आजकल जितना ई वेस्ट आ रहा है, पीपल दे आर नॉट, सपोज दे यू हैव यूज्ड योर लैपटॉप फॉर 5 to 6 years एंड उसका कुछ पार्ट्स खराब हो गया है. सो व्हाट यू विल डू, इंस्टेड ऑफ इन्वेस्टिंग 7 to 8,000 in that laptop, what you will do, I will put some 20,000 into it and I will get the new one. Okay, so in this way the people are thinking and they are buying the new things, new electronic gadgets, and they are just dumping those old one. जैसे घर का टीवी खराब हो गया, अरे ठीक है ना, 10 साल यूज किया, नाउ वी विल टेक द न्यू वन, फेंक दो उसको. उसी तरह से फ्रिज बहुत यूज हो गया, चलो फेंक दो उसको. सो नाउ द पीपल आर डूइंग लाइक दैट. पहले ऐसा नहीं था, कोई भी चीज था तो उसके पार्ट्स अवेलेबल भी रहते थे एंड पीपल यूज टू यूज दैट फॉर ए लॉन्गर पीरियड ऑफ टाइम. Okay, they repair those things and they use it for longer period of time, but now they are not doing it. They are thinking that investing in the same thing is if investing into the same it's better to buy new product. Okay, so here you can see that the shape has not changed, it is as it is. So these the interlinking which we can see between the polymer chains, they are strong covalent bonds. They are strong covalent bonds between polymer molecules or chains which cannot be easily broken down. Okay, तो वो आपका ब्रेक होगा ही नहीं, कितना भी आप उसको हाई टेम्परेचर पे हीट करोगे, still they cannot break, and polymer keeps shape on heating also. So it is not going to change, it is going to keep its shape as it is. And if you want to more heat that, you want to heat that polymer more, then also they will just burn and they will make a big mass of that carbon. Okay, because you know that polymer is nothing but it is a long chain of carbon, hydrocarbons. So that carbon will burn and it will give you a big mass, but they are not going to be remolded into another shape and size. Okay, so these kind of polymers, they have extensive cross links formed by covalent bonds. Then bonds prevent chains moving relative to each other. I told you earlier also that what these bonds helps in. If these intercross links are not there in the polymer, then the polymer chains move from one on one another and slide from one another, and because of that the bonds can be easily broken down. But here the bonds prevent the movement of the polymer chain on each other. Okay, तो वो आपको slide होने नहीं देगा. These polymer chains will not slide over one another. So because of that, the bonds between them are very strong bonds. They cannot be broken down easily. So cannot be remolded into any desired shape. Okay. So have you understood, students, that the points of thermo-softening and thermosetting plastics? Yes, is the idea clear to you?
Yes.
Yes, ma'am.
Okay. So we will move to the next. So these are the in short, in a single slide, I have put these two types of polymers, that is thermosoftening, which is known as thermoplastic, and thermosetting, which is known as thermoset. So here you can see the structure also, that they have straight chain, or you can have branched, maximum to maximum they can be branch chain. But here you can see the cross link, wo pura jumbled up hai. They are all cross, they are three-dimensional network chain structure. So these all blue color lines, they are the cross links between the polymer chains. So here I have noted down some points regarding the thermosoftening and some points regarding the thermosetting polymers. So in thermosoftening, you can see tangled polymer chains, no cross links between the chains, weak forces of attraction between the chains, and they get softened while heating. So on heating, they will become soft and they can be remolded into any desired shape. Whereas thermosetting, they have polymer chains held together by strong cross-linked bonds that does not break on heating also, and because of that they remains hard when heated. So they will, if you will heat at very high temperature, they will become a hard mass of carbon, but they cannot be molded into any desired shape and size. Okay. So these are examples of some thermoplastics, or you can say thermosoftening polymers. So thermoplastics means thermosoftening plastics. So we have polycarbonates. These are the structure of polycarbonates. Then we have polyethylene tetrasulfate. Okay, PET. We call it as PET. Polyethylene tetrasulfate, which is also a polyester. Then polyamide amide group, hexamethylene adipic amide. So this, which we call it as nylon 6,6. So these are some examples of, so they can be all remolded into any desired shape. These are some examples of thermosetting polymers. So these are basically your phenol and also your जो हम लोग ने पढ़ा है simple polymers like polythene, polypropylene. Then we have studied polyvinyl chloride. Of course, these are all thermosoftening plastics, so they can also be remolded. And these are thermosetting plastics, where you can see the phenolic groups which they have. Then amines, polyesters, also epoxides, then urethanes, silicone rubbers. All these are the thermosetting type of plastics. Okay. Is it clear, students? And here their applications are written, that where these kind of thermosetting polymers can be used. Once what happened, so this is the difference. So we will see the difference. Just I want to share one experience which I have faced at my home regarding this polymer only. So when my daughter was small, 1 year old, she was taking the feeding bottle. Okay, and you know that nipple of that bottle is made up of silicone rubber. Okay, आपको soft रहता है ना एकदम, silicone rubber का रहता है वो. तो वो सबको हम लोग स्टेरलाइज करते हैं. Bottles we first sterilize it and then we use it for feeding our kid. So what happened in night, I kept it for sterilization. I took water into a tub and I put that bottle as well as its cap, the nipple, all I put into that, and I went inside and I forgot that I have kept something for sterilization. Okay, bottles. I forgot and I slept also. Okay, so at midnight, I saw there's lot of fumes at my home, and we all were coughing. Myself, my husband, my small baby, we all were coughing a lot. Then I thought, why there is a lot of fumes at our house? I just went into my kitchen and then I saw that lot of fumes were coming from that vessel. So I just put the knob off, and then I saw it whole, that bottle, the nipple, that this cap of that, everything was a black color mass in that container. Okay, so पूरा वो black color का mass, nothing was seen into that. वो पूरा आपका जल के पूरा वो कार्बन ब्लैक जैसा रहता है ना, वैसा ब्लैक कलर का पूरा मास बन गया था, सॉलिड मास. And nothing, you cannot identify that before 2 hours there was something into uh, that vessel. Okay, so it was all a black color mass into that vessel. Then we opened the windows and all, and we allowed the that fumes, and that fume was also very toxic. Okay, because it was all silicon and all, so it was very toxic. We were coughing like anything, and tears were coming from our eyes. That kind of situation was there only because of one bottle which was burnt completely, and it became the carbon mass. Okay, so that was nothing but that was the thermosetting type of polymer. Okay, पूरा वो आपका जल के कार्बन ब्लैक कलर का आपका बन गया, लेकिन आप उसमें से कुछ भी, nothing was visible into it, only it was a black color mass. So these kind of तो मैंने खुद घर में वो देखा कि वो थर्मोसेटिंग अगर जलता है तो कैसा दिखता है. So it becomes a black color solid mass, it becomes. Okay, and then you cannot clean. I was not able to clean that utensil, and I have thrown it out. Okay, because it was all stick to that. पूरा उसके अंदर black color का जम गया था. So at the end I have thrown it. So now we will see the difference between thermoplastics and thermosetting plastics, that is thermosoftening and thermosetting. This is very important question for your exam, students. It comes for 4 marks. So first is, these are materials which soften on heating and become hard on cooling. कौन सा? Thermoplastics. They can be softened. That means we can mold it into any desired shape. तो आप उसको अगर पिघलाओगे तो वो पिघल के आपका रबड़ के जैसा soft हो जाएगा. And the same material can be reused for making another article. So these materials which become soft on heating and becomes hard on cooling. But these kind of materials which become permanently hard and rigid on cooling when heated. If you are going to heat thermosetting materials, they are going to become very hard, rigid, solid mass. They cannot be softened and they cannot be remolded also. Then thermosoftening can be remolded and reshaped, but thermosetting, they cannot be remolded and reshaped. Then the next is, they are soft, weak, and less brittle. But whereas thermosetting plastics, they are hard, strong, and more brittle. They are linked by weak van der Waals forces, but whereas thermoplastics, they are linked by strong covalent forces. They have low molecular weight as compared, of course they have high molecular weight, but as compared to thermosetting, they have low molecular weight as yes, but yes.
ये लिख के लेना है क्या डिफरेंस?
नहीं, आपको मैं ये रहेगा ना, नोट्स में भी है और स्लाइड्स में भी है, राइट? ओके, so thermosoftening, they have low molecular weight, and thermosetting, as they are cross-linked structure, so they have high molecular weight. Then thermosoftening polymers, they are soluble in organic solvents, but these polymers, they are insoluble in organic solvents also. Okay, like alcohol, then benzene, like phenol, in that also they cannot be dissolved, thermosetting. Then thermoplastics, they consist of linear long chain structures, or it can be branched also, but they have 3-dimensional cross-linked structure. They are prepared by addition polymerization. जो आपका thermosoftening plastics है, they can be prepared by addition polymerization, where whatever we are going to add, the monomers, they will add together and no byproduct will be formed. But in case of thermosetting polymers, along with your product, some byproducts are going to be formed. Okay, so thermosettings are prepared by condensation polymerization. Then they may be amorphous or crystalline. Thermoplastics can be amorphous in nature or it may be crystalline also. दोनों हो सकता है. But here they may be liquid or solids. यहाँ पे ये आपका liquid रहेगा या फिर direct solid में convert होगा. They cannot be amorphous or crystalline. Then they are more convenient for superior surface finishing. Okay, when these thermosoftening plastics are prepared, articles of these thermosoftening polymers are prepared, they have very good surface finish, ekdam smooth. These are toys, buckets, mugs. You can see that they are very soft, smooth surface has been formed. But in case of thermosoftening polymers, they are more difficult for surface finishing. तो अगर इसको हम लोग यूज भी करें बाय चांस फॉर प्रिपरेशन और मोल्डिंग पर्पस फॉर मेकिंग आर्टिकल्स, then your surface will not be very smooth and shiny. Okay, there will be some mark left on that polymer. Like example here, I have written PVC, Teflon, polyethylene, all are examples of the thermosoftening plastic. And here the examples are bakelite, urea formaldehyde, phenol formaldehyde, polyesters, etc. So bakelite, which we have prepared in lab, that is an example of thermosetting polymer. And we saw that along with the solid mass, there was some water molecules also which was liberated in the reaction, during the reaction. Okay, so this is the different points. तो ये आपका 4 marks का आता है, 1, and how many points are there? Maximum you have to write 8 points. Okay, so half marks for 1 point. Is it clear, students?
Yes, ma'am.
Yes, ma'am.
Any doubt? Anything you want to clear? Nothing? Everything is clear to you. There may be 2 options when you are keeping quiet. Either you have understood everything or you have not understood anything. So what I should expect?
Understood, ma'am.
Yes? Understood. Okay. Very good. Very good. Okay, now we will see the next part of the plastic, that is known as compounding of plastics. Now, what is this compounding of plastic? Compounding of plastic is nothing but the original plastic which is prepared in lab that have low properties. Their properties are not enough to be used in industries. है तो plastic, they have all the properties also, but not those properties because of which we can use it in industry. Okay, so to make it industry use, we have to add certain things based on the requirement of the industry. Suppose one industry, they require the thermoplastics, which is hard also, which is look like glass also. Okay, like your to make suppose windows of aeroplanes. Okay, so aeroplane windows, they are nothing, they are made up of these plastics. Okay, so that kind of suppose material we want, or we want the polymer to be used for the wheels of the aeroplanes, which can withstand very high frictional heat. क्योंकि जब वो एकदम लैंड करता है तो आपका एकदम बहुत फास्ट जमीन से घिसता है, तो वहां पे क्या होता है, lot of frictional heat is developed. So these kind of polymers, if we want to be used in industry, then we have to add certain things into that plastic during its manufacturing. Okay, not after the manufacturing of the plastic. So during its manufacturing process only, we have to keep it in mind that this plastic has to go to which industry, and before because of that, what we have to add into it. So whatever the components are added into the plastic during its manufacturing, that is known as compounding of plastics. Okay, so here, Manan, now you are entering. Just a minute. Okay, so what are these substances? The substances which are added during the formation of plastic to improve their properties are called compounding of plastics. So some properties, of course, it is there with the plastic, but we have to improve those properties. So for that, we have to add extra things into extra substances into that plastic during its manufacturing. Then that is known as, that process is known as compounding of plastics. So what is that? The substances which are added during the formation of plastic to improve their properties are called compounding of plastic. So what things we are going to add during the manufacturing of plastic? We are going to add these substances like resins or binders, plasticizers, fillers or extenders, dyes and pigments, lubricants, and last is accelerators or catalyst. So these are the and stabilizers. So these are the things or substances which we have to add into the plastics during its manufacturing so that their property can improve and we can use it for industrial application. Are you getting it, students? Hello?
Yes.
Am I audible?
Yes, ma'am.
Okay, so these are the things or substances which we are going to add. So now in detail, we have to study that what are these substances along with examples. Okay, जैसे कौन कौन से रेजिन्स हम ऐड कर सकते हैं, प्लास्टिसाइजर क्या ऐड कर सकते हैं, इसका पर्पस क्या है, why we are adding into it. So all that we will study in detail one by one. So first we will go to the resins or binders. So this is the process, manufacturing of plastic. As I told you, during its manufacturing, we add these compounds. Okay, so this is the whole polymer process. देख रहे हो यहाँ पे ये resins है, fillers, plasticizers, additives, all are added into this extruder. मतलब इसमें सब आपको mix करना है. Then after that, we are going to make the homogeneous mixture of this, and then this mixture is passed into the molds. So this is the screw molding where we are going to study these molding techniques separately. So from these molds, we will get the desired product, and that can be again washed in water, heat, cool down, and you get the desired article. So this is the whole process. So we have to add all these additives along with the polymer. तो सिर्फ पॉलीमर हमको नहीं यूज करना है, अब पॉलीम प्लास्टिक्स उसके साथ साथ हमको ये सारी चीजें भी ऐड करनी है, substances which improve the property of the polymer or the plastic. So one by one we will see. First we will see resins or binders. So binders, what do you mean by binders? Yes, students, what do you mean by binders?
कंबाइन, दो को जोड़ने वाला.
Yes, दो चीजों को जोड़ने वाला या पूरा पकड़ के रखने वाला. Okay, so here we are going to add these binders into the plastic so that it will bind all the constituents of the plastic together. Okay, तो bind करके रखेगा. So here we can use what is this binders? They can hold the different constituents of the polymer together. Major constituent of the plastic is almost 30 to 90%. So these binders or resins, they are constitute the major proportion of the plastic. तो जो हम लोग अभी प्रोसेस देखा बनाने में, उसमें हम लोग का मैक्सिमम क्वांटिटी क्या रहता है? बाइंडर्स या फिर resins. So resins, why we have written? So low molecular weight resins or polymers can be used as binders also, like polyethylene, polypropylene, polyvinyl chloride. These are simple straight chain polymers, and they have low molecular weight as compared to the other. So because of that, we can use these small resins or the polymers, low molecular weight polymers, as binders also. So the major constituent of any plastic will be this resins or the binders. So how much we will add? Around 30 to 90, 30, 40, 50, any percentage. So maximum will be it. Then it can be natural or synthetic resin or cellulose derivatives. हम लोग इसके अंदर अभी किस टाइप का आप ये बाइंडर्स यूज कर सकते हैं? वो नेचुरल भी हो सकता है, जैसे नेचुरल में क्या, वुड पाउडर, वुड हस्क. ओके, देन और क्या यूज कर सकते हैं? मेटल पाउडर, metal oxide powders. Okay, so natural also we can use. Synthetic resins like polypropylene, polyethylene, polyvinyl chloride, all can also be used. or we can also use cellulose derivatives. Okay, so these are also natural. So we can use natural, synthetic, or cellulose derivatives as a binder. So if low molecular weight resins or binder is used, the plastic gets molded easily. Okay, इसलिए मैंने आपको बोला कि हम लोग यहाँ पे usually resins use करते हैं, low molecular weight resins like polyethylene, polypropylene, all these, so that the molding property of that plastic will be improved to a very high extent. If these low molecular weight resins are used as the binders, then you can reshape again and again that plastic into any desired shape and size. Then it also decides the type of treatment needed to mold the articles from the plastic. तो कौन सा आप resins add कर रहे हो, whether it is natural, synthetic, or cellulose derivative, or low molecular weight resins. So depending upon that, you have to decide that which treatment method we have to use for molding technique. So there are different kinds of molding techniques which we will study afterwards. So depending upon the amount of, or depending upon the type of resin we have used in the plastic, we have to decide that what kind of molding technique we have to use. Then, for example, these are the low molecular weight polymers or resins like PVC, polyvinyl chloride, polyethylene, polystyrene, polypropylene. All these are the low molecular weight resins which can be used as binders also. Okay, तो इस तरह का रहता है आपका. देखो, these are the binders. They can be in liquid form, they can be in solid form. Solid में है तो आप उसको ये करके melt करके आप उसको during the synthesis of plastics you can use. So these are the binders or resins. Okay, students, clear? समझ में आया binders क्या है?
Yes, ma'am.
Now next one is plasticizers. Second substance which we add into the plastic is plasticizers. So why we add plasticizers? So that it will improve the plasticity property of the polymer or the plastic. So the proportion of plasticizer added is almost 60%. Okay, तो 60% तक आप लोग plasticizers उसके अंदर add कर सकते हैं. So these plasticizers, they are going to improve the properties like flexibility of the substance, flexibility of the article, plasticity of the thermosetting plastic. Because we know that thermosetting plastics are very hard and it cannot be made soft while heating. So what we have to do during its preparation of the plastic, we can add this plasticizer so that after synthesis of this thermosetting plastics, they can be remolded also. They have flexibility, they have plasticity, okay, property. So these plasticizers can be added only in the thermosetting. Thermosoftening में डालने की जरूरत नहीं, because already they are very soft and flexible. अगर कभी जरूरत पड़ा तो small quantity, but in case of thermosetting, we are adding 60% of this plasticizer. So you can understand that how much these plastics are hard, so that we have adding 60% of substance which will increase its plasticity and flexibility. The next is that decreases the tensile strength and chemical resistance. So thermosetting plastics, they are very hard, rigid, strong. So they, of course, they have high tensile strength. But when you are adding these compounds at plasticizers, they are going to decrease the tensile strength. But foldability, flexibility, plasticity, all these properties will improve, whereas tensile strength, chemical resistance, these properties are going to decrease. Then it reduces the temperature and pressure required for molding. Of course, because if it will be very hard, then we have to apply more temperature, more pressure, more catalyst we have to add. But when it is soft, flexible, easily moldable, then we have to apply very less temperature and pressure. Okay, that article can be easily molded at minimum temperature also. So it reduces the temperature and pressure required for molding. Then it reduces the brittleness because it is flexible, soft, so brittle nahi hoga aapka. Increases flame proofness. Okay, so it is going to increase the flame proof. मतलब आप उसको कितना भी जलाओगे तो आपका वो जलेगा नहीं, flame proof रहेगा. For example, these are the example of plasticizers which can be added: camphor, triphenyl phosphate, tributyl phosphate, triacetylene, then non-drying vegetable oils. So these can be used as the plasticizers into the thermosetting plastics, especially I am saying thermosoftening में भी use करते हैं, but to less extent. But especially in thermosetting plastics, 60% of these plasticizers are used, okay, to improve its tensile flexibility and plasticity property. So these are the compounds, plasticizers, which can be added into the plastic during its manufacturing process: camphor, triphenyl phosphate, tributyl phosphate, triacetylene, and non-drying vegetable oils. So these kind of compounds are available in the market. ये अक्षर केमिकल का है, ट्राईएसिटिन. ओके, तो ट्राईएसिटिन आप लेके आप यूज कर सकते हैं ड्यूरिंग द सिंथेसिस ऑफ प्लास्टिक्स. Then we have fillers or extenders. Fillers means just उसमें to increase the volume, okay, fill करने के लिए, to increase its volume, we can use these fillers or extenders. So what are these fillers? The proportion of filler should be added is 50%. 50% आप fillers add कर सकते हैं. Then it improves the hardness, tensile strength, opacity, finishing and workability of the plastic. तो प्लास्टिक में आप ये फिलर्स ऐड करने से क्या होगा, उसकी कौन कौन सी प्रॉपर्टी इंप्रूव होगी? हार्ड हो जाएगा आपका, क्योंकि उसके अंदर पूरा फिल कर दिया आपने, लाइक कार्बन फाइबर्स, और यू कैन ऐड पॉलीमर फाइबर्स और पॉलीमर ग्रैन्यूल्स, और यू कैन ऐड हस्क जो आपका ऑर्गेनिक कंपाउंड है. So that can also be used. Wood powder you can use, okay. Mica, talc, all that can be used. So it improves hardness, tensile strength भी उसका बढ़ेगा. It will become opaque. Okay, पहले आपका बहुत transparent है, तो वो डालने से क्या होगा, opacity will be coming. Finishing, उसका अच्छा finish आएगा. Whatever the article will be made, that will be with good finish. Then workability will also increase. तो उसका जितना मतलब अगर वर्क उसको आप हेवी ड्यूटी वर्क के लिए नहीं यूज कर सकते, तो आप उसको हेवी ड्यूटी में भी यूज कर सकते हैं. इट रिड्यूसेस द कॉस्ट बिकॉज फिलर्स विच वी आर एडिंग दैट इज ऑफ लो कॉस्ट. ओके, तो वो आप ऐड करने के बाद यू कैन रिड्यूस द कॉस्ट ऑफ द पॉलीमर. श्रिंकेज ऑन सेटिंग एंड ब्रिटलनेस ऑफ प्लास्टिक कैन ऑल्सो बी रिड्यूस्ड. Like example, you can see what we can add. We can add quartz, mica, all these which increases the hardness. So this is your mica. Okay, this is basically a stone. आपको जब हम लोग सिविल लैब लेके गए थे, वहां देखो जियोलॉजिकल लैब, वहां पे वो मैडम ने आपको बहुत सारे टाइप्स के दिखाए थे स्टोन्स. Okay, so these are basically quartz, mica, etc. This is your mica. फिर हम लोग और क्या ऐड कर सकते हैं? Asbestos we can add. It increases heat and corrosion resistant. So whatever the requirement of the industry is there, so based on that we can add. अगर आपको industry बोलता है we want the polymer which is very hard in nature, so you can add the filler quartz into it. If they want the corrosion resistant polymer, so in that you can add the asbestos powder as the fillers. Okay, so depending upon the requirement of the industry, you have to add these compounds or substances. So this is your asbestos. आपको पता है रूफ के लिए भी हम लोग यूज करते हैं, ऊपर रूफिंग के लिए. Yes, do you know students? देखा है आपने एस्बेस्टस शीट्स देखे?
अठारह ना.
Yes, ma'am. रॉ में रहता है तो
हाँ, ऊपर घर का छत डालने के लिए यूज कर, रूफ के लिए यूज करते हैं एस्बेस्टस.
पत्रा ना. Yes.
देन फिर हाँ Okay, fillers are also classified into two types. So we can classify depending upon the need requirement. We can say that we can use organic fillers as well as organic fillers. So organic fillers में हम लोग क्या क्या ऐड कर सकते हैं? We can add cotton, wool, flour, graphite, paper, pulp. All these can be used as the organic fillers. And inorganic fillers are your talc, asbestos, mica, silicate, oxides of metals, sulfides of metals, metals like copper, aluminium, iron, etc. in form of powder. So all in form of powder, granules, fibers, they can be used and they are known as fillers. So organic fillers and inorganic fillers. ठीक है, समझ में आया?
Yes, ma'am.
Yes,
Okay,
ma'am.
so it's already
lecture PM.
10:59. Yes,
No, madam.
that's what
No,
I'm
no.
stopping here. Some more substances are remaining. Only we have done 3. The remaining four are there. So that we will do in the next class. Just you remind me in the next class that till okay. So now we will take the attendance and we will stop the class.